Hi guys. Okay, so we've got a quick demo. So I wrote this program earlier. It's pretty basic. All it is a few nested function calls with where we're assigning a few local variables. So we're assigning a local variable and another one. Then we're calling a function with them as parameters. Then we're going to assign some other variable. We're going to call another function here, return a value. So it's not very complicated. You can take a look at it. You can pause it if you want to take a look at the code, but we'll be stepping through it here anyway. So it's cool. So right, okay. So first couple of instructions. So the first instruction is essentially taking whatever's stored in this memory address and it's storing this memory address in a location that is calculated by using the base pointer as the offset, right? So as I described before, the base pointer points to the bottom of the stack frame, and it's used as a way of calculating where the local variables are. So this particular offset here, EBP minus hex C, is going to be the memory address for this character pointer, and what we're doing is we're just storing this memory address in which contains this string, as we can see if we can do this. We can see that that memory address contains string AA, right, cool, all straightforward. Same again here, we're using the base pointer to calculate where the this variable sits, and then we're storing hex 3, which is just the number 3 in there. And we're stepping to the next instruction. Okay, so now we're about to call the function. First thing that happens is we need to expand the stack, right? So what we're doing is we're subtracting 8 from the we're subtracting the value 8 from the stack pointer, which makes it bigger because, as we know, the stack grows downwards from high memory to low memory, so we actually subtract in order to make the space larger. After that, we are then pushing our two. We're pushing these two parameters onto the stack. So one thing to note is that in this current calling, in the calling convention for the for GCC with 32-bit on Linux, the rightmost parameter gets pushed first. So as you can see here, we stored the 3 in the integer in the variable var2int. That's the right hand side of the function call. That's getting pushed first, and then we're pushing the other one to the stack. And what we can do here is we can actually look at the next 8 instructions. Sorry, from the stack pointer. Okay, so we can see that we've actually pushed the 3 to the stack, then we've pushed this memory location that has AAA to the stack, and now we're about to call the function, right? So one thing to note before we actually call the function is the next instruction that we want to execute once we've returned from the function, from the main function, from this call here on line 20 in the main function, is going to be, the next instruction is going to be at this memory location, memory address, right? So ends in 1D0. So what we're going to expect here to happen is that when we call the function with this memory address, which is here, the start of function 1, what actually is going to happen is it's going to push this onto the stack as a return address. So we've stepped within it, right? So if we quickly look at the stack point, the next 8 things on the stack, we can see that it's actually changed. This element wasn't here before. It was like that, right? So we've just pushed this new thing on top of the stack, and that is the address that we want to return to. Okay, so function parameters gets pushed first, then the stack, then the return address. Sorry. Now what happens when we're just setting up the function? We've just entered the function. What we're doing now is we're going to update the base pointer. So we're going to push the old base pointer onto the stack so that we've got a reference to it. So now we've got local parameters. Sorry, we've got the parameters, then we've got the return address, then we've got the base pointer on the stack. So if we look there, we've got the base pointer on the stack as well, so we can calculate our offsets correctly for this particular function. If we're looking at so we'll next step is we're actually updating our base pointer to whatever the previous stack pointer was, and as we remember, the stack pointer points to the top of the stack. So as we're creating a new frame, we're just going to take that value that's pointing to the top of the stack and then set that as our new base pointer for the next frame, right? And then we'll end up, the next step is we're then going to increment, we're going to increase the value of the stack pointer to give us more space on the stack, right? But because it grows downwards, we're actually subtracting from a higher memory address to a lower memory address to add more space on the stack. Right, cool. So we're now within the second function. We've got our stack pointer and base pointer set up, all good. We've got our parameters on the function, and now we're going to define some local variables, which are going to be it's similar to before. We're calculating where they go based on the offset from the base pointer. The new base pointer, the one for function 1 now, right? Because we've just changed it here. And we're then going to call another function, okay? Okay, so let's just step inside the next function. Okay, so yeah, we're doing the same again. Base pointer is updated, stack pointer is updated. Here we're increasing the base pointer is updated, stack pointer has been expanded. Now we're just storing 0 in this variable, we're storing 99 in this variable, and now we're returning the contents of this variable, right? And in order to do that, we're first going to move it into the EAX register so that the previous function can then look in the EAX register to get whatever we've returned from the function. Right, before that happens, we do a leave instruction, and leave pretty much works the opposite of this. So it's a way, so instead of, so it's updating the base pointer again and the stack pointer, but instead of making it bigger, it's making it smaller. Return will then pop the instruction from the top of the stack. So if we look here, we can see, sorry, I'll pop the address from the top of the stack and stick it in our instruction pointer, right? So this is the address that's currently at the top of the stack before we run return, and if we look down at where that is, we can see that it'll be just after our function 2 call, right? So here, so this will get returned. So when we hit return, this will get put into our instruction pointer, and we'll carry on execution from here. So if we step again, we'll see that that's exactly what happens. Now what we're doing is we're getting whatever was in EAX, which was our return value from the function above. So we can actually just print that out. So it's got 99 in it, right? Because we set this value to 99, then we shoved it in here to return it. So what it does, it gets stuck in EAX. It gets shoved in EAX. We're then grabbing it out of EAX and putting it into this local variable, which we're calculating based on the offset of the base pointer that we've just updated, because we're back in function 1. And that's pretty much it. Now we're just, there's not really much more to talk about, to be honest. So yeah, I'll leave it with that. That's probably enough. I hope that was useful. Cheers.